Okay guys, now let's talk about reflections of graphs. So, reflections of the x-axis. The graph of y equals negative f of x is the graph of y equals f of x reflected on the x-axis. So let's do a couple of these. So we have f of x equals x squared. So I'm not going to do the work, I'm just going to put in the ordered pairs. I know you guys are good enough to do that now. So if we square 2, we're going to get 4. I'm going to put in 0, get 0. And if we put in negative 2, if we square negative 2, that is going to give us a positive 4, right? So let's graph that. Start at the origin. Positive 2 gives us 4, and negative 2 gives us 4. So we could graph that parabola, right? Because x squared always gives us a parabola. And then if we want to just fudge and do 1, there we go, something like that. I'm not a master grapher by any means. I had one in, when I was going to school. He was awesome. I do not pretend to be that. Okay, now let's do negative x squared. Okay. So if we plug in 2, square that, it's going to be a negative 4, right? Because we square 2, the negatives on the outside just give us a negative 4. Plug in a 0, we still get 0. And then if we plug in a negative 2, that's going to give us a negative 4. So if we graph this, we're going to still start at the origin. I'm going to make a circle around him so you can see we share that. If we go to negative 2, we get a negative 4. If we go to positive 2, we get a positive 4. So it would look like this. Okay, just like that. So you can see that it's reflected about the x-axis. Sorry, I'm trying to keep my paper straight. Failing, but trying. Okay, so there is the reflection about the x-axis. Now, here is another one. We have f of x equals the cubed root of x. So if we plug in 8, we're going to get 2. Oh, I did not mean to write equals. I can find my whiteout. Sorry for that. Should be a comma. 0, we're going to get 0. If we plug in a negative 8, then we're going to get a negative 2. Okay. Over here, we're going to have negative cubed root of x. Plug in 8, we're going to get negative 2. 0, well again we get 0. And then if we plug in a negative 8, we're going to get a positive 2. Okay, so let's graph the first one. Start at the origin. If we have 8, we're going to get 2, and negative 8, and negative 2. Be kind with my graphing skills, please. Something close to that. And then now it's going to be the opposite. At negative 8, we're going to get positive 2. Again, share the origin. And then at positive 8, we're going to get negative 2. That was terrible right there, I'm sorry. But they would be completely opposite. It would be reflected about the y-axis is what I'm trying to say. Except for my drawing, it's not very good. Okay? So that's how you would do that. Now, on the y-axis, same idea, different axis. So the graph of y equals f of x, y equals f of negative x is the graph of y equals f of x reflected about the y-axis, okay? So we're going to use the graph of f of x equals the square root of x to obtain the graph of h of x equals negative h of x equals the square root of negative x. Okay, so let's go. We have the square root of x equals f of x. We've done this one enough, you guys could probably do it in your sleep now. So 4, 2, 1 and 1, and 0 and 0. Okay, so we start at our origin, 1 and 1, and then 4 and 2. So we could graph this. Now, we have the square root of negative x equals h of x. Man, I'm having a hard time talking this morning. Okay. So if we plug in a negative 4, right, so it'd be a negative 4, that's going to give us a positive 2. If we plug in a negative 1, which again would be a negative 1, that's going to give us a positive 1. Then if we plug in, well, a 0, that's going to give us a 0. So we'll share an origin again. And then negative 1, positive 1, negative 4, positive 2. So it'll look like this. So it's reflected about the y-axis. All right, let's talk about vertical stretching and shrinking. Okay. So let f be a function and c be a positive number, real number. That's just like pretty much everything else. So if c is greater than 1, the graph of y equals c times f of x is the graph of y equals f of x vertically stretched, okay, by multiplying each of its y coordinates by c. If 0 is less than c is less than 1, the graph of y equals c times f of x is the graph of y equals f of x vertically shrunk by multiplying each of the y coordinates by c. So if it's greater than 1, it stretches. If it's between 0 and 1, it shrinks. So here's my simple speak. If you multiply a function by a number greater than 1, it gets taller. If you multiply a function by a number between 0 and 1, it gets shorter. Okay? So let's kind of look at this one. So if we have x cubed, we plug in a 2, we're going to get an 8, right? 2 cubed equals 8. I should say this equals f of x, probably. If we plug in a 1, well, we're going to get a 1. A 0, output is 0. Input of negative 1 gives us output of negative 1. And negative 2, well, gives us a negative 8. Okay? So we could graph this. Oh, sorry. Jeez, epic teacher fail right there. Okay. So we're going to start at 0, 0, 1, 1, and 2, 8. -1, -1, and -2, -8. So this is our original f of x. Sorry. Now let's do 2x. Okay. So when we do this, our x's stay the same. But we multiply 2 times our y's, right? Because this is vertically getting taller. So, well, 2 times 8, 2 times 1, that's still 0, -2, and -16. Okay? So then we just graph that. Again, we're here at the origin. 1, 2, and 2, 16. So this is 11. We're going to say 16's up, yeah, here. -1, 2, and -2. I don't know, 16 can be somewhere down here. Okay. So that's our stretch. Now let's do our shrink. Again, we multiply 1/2 times our y. So we could just copy and paste our x's again. So 1/2 times 8 gives us 4. 1/2 times 1, well, 1/2. 0. -1/2 and -4. So that will be our last graph. So again, at the origin, this one's going to be 1/2, and here 1/2, and then 2 is going to be 4, and this 2 is going to be 4. So it's going to be like, so you can see the difference of the coefficient makes. Sorry, so crooked. Okay. Alright, so that's the end of this video, and I will make another one for the very last part of this transformations. Okay? Have a great day.